So this is a diagram of what the inside of the vein looks like. We know that deoxygenated blood travels in the veins for the most part, and it travels at low pressure. And it has to be returned to the heart in order for the heart to pump it to the lungs to be oxygenated again. We have one-way valves found inside the veins. They are found at frequent intervals. Here's a valve, for example. You can see it looks like a gateway. It is called a one-way valve because it allows the flow of blood in one direction only, and in this specific valve it is from down to up. It only allows blood to flow upwards and does not allow blood to flow back downwards. And this is important because blood is traveling at low pressure, so we have a risk of losing blood flow and having blood travel backward, and we need blood to stay flowing in one direction. This is blood that we need to deliver to the heart. So the valves prevent the backflow of blood in the veins. The valves will close the second blood starts to flow backwards and prevents this backflow. And also veins, especially the larger ones, since the bigger the volume, the lower the blood pressure inside of the vein. Many of the large veins are found between large muscles in the body, especially in your legs, for example. So the contraction of the muscles help, as you can see here, it's like they're pulsating in order to increase pressure. So you can see right now we have pulsating, we have increased pressure, then the pressure decreases and the valves help prevent the backflow until the next time the muscles contract and we have more pressure. So this helps keep the blood circulation going even with the low blood pressure found in the veins. If we didn't have valves and we didn't have the situation between the muscles, then blood flow would probably flow back or slow down a lot more, or it might even stop. So the structure of the veins is very important.